Assalamualaikum warahmatullahi wabarakatuh. My name is ISMAIL and I will explain answer of question 1. So on question 1, we need to put out the information that you give. So X is number of microchip that 4, Y equal to number of resistor equals to 2 and capacitor is equal to 1. So he give that X is microchip and Y is resistor. Require us to show the joint probability distribution and marginal distribution of X and Y. And then we need to do a table and show that y x 0 1 2 3 0 1 2 3, and we need to find the value inside of the table. So how to find the value of inside in the table? We use a formula for this formula that I choose Z on the capacitor to explain how the basic formula is. So if we need to choose only 3 things, like, so if x equal to, if microchip is 1 and y equal to resistor is equal to 1, so capacitor also needs equal to 1 because of we need 3 things of it. So with this formula we can find value on this. How to find the marginal distribution of x and y? So we need to search for gx and hy. So we give after we find this value, we need to sum of it. So if x equal to 0 and then y equal to 0, we need to sum the x equal to 0. So x equal to 0 is 1/35 and so on. After that we move to the next question. He asked that are x and y are independent. So we just f1 and fx1 and y1. We look at the table. x1 y1 equal to 8/35. And then we look at sum of x equal to 1 and y equal to 1. Sum of 1 is 12/35 and h1 is 4/7. We need to multiply and we get the value of 48/245 and 8/35, which means that they are not equivalent. So the x and y are not independent. Okay, so the question 3 it requires us to determine the ex and ey, which means that mean of x and mean of y. So the formula is x multiplied with gx. So x0 and gx of 0 is 1/35. Until the x is 3, we need to multiply in plus of it, and we got the answer is 12/7. And the mean of y, we also need to do the same formula, which means that y multiplied with hy, 0 multiplied with the value of y0 is, sum of y0 is 2/7, and we follow, and then we got the answer is 6/7. So the question B, he gave us a joint probability distribution. So we need to find the marginal distribution of x and y. So it's same like the other question. We just sum of x1 that he gives, because from the answer of question 1 we need to find the joint probability distribution, and now we need to find marginal distribution of x. So we plus of x1 is equal to 43/100 and sum of x2 is 57/100. Same with marginal distribution of y, we need to sum of y equal to 1 or 2 or 3, which means that 39/100, 7/20 and 13/3. Px more or same or more to and y equal to 2. So we use the formation of y go to below and x go to, so f2 is equal to x and y on the table. So the f2y and the joint probability distribution, we got the value is 0.22, and h2 is the sum of h2 on here. We get a 7/20, and we get the answer is 22/32. So we asked to calculate the covariance of x and y. So the formula of covariance is exy minus v, ex multiple with ey. So we need to find the ex first. X equal x multiplied with gx. So 1 multiplied with 40. The value is the sum of x. Yeah, that we find in the table. and we get the 157 over 100, and EY we also need to do the same y multiple with HY. So we get here and we get the value from the table, and we get down to 187 over 100. Okay, so for the EXY, we have a formula that he used to looking for it. So the formula is XY multiple with FXY. So FXY when we get on the joint probability distribution. Okay, so X and Y we just look at the total probability distribution, and Y multiple with 1, the value of FXY is 0.15. So we continue to find on the table, and the value of we get for EXY is 72 over 25. Alright, so if we get all this required information, we can search for covariance of it. So 72 over 25 minus with 157 over 100 and multiple with 187 over 100. So the covariance is negative 559 over 10,000. So that's all for the question 1. So let's move to the next question.
Okay, I'm DANISH, so I will be presenting question 2. For marginal density for x, we have to use limit y because we want to eliminate the y and remain the x. So we use the limit y 0 until 4, take back the density function, and dy because we want to eliminate y. So and then we integrate and we get 1 over 60 equals to 8x plus 8. The important thing is we have to write the limit for x because they want marginal density x. So okay, for the marginal density y, we use the limit of x that is 0 until 3 and dx. So we integrate the density function and we will get 1 over 60 9 plus 3y. Like I said, the important thing is we have to write back the limit of y because we want the marginal density of y. We have to see the limit, either we want to use x or we want to use y because we have to double integrate dx dy. So we determine either the inner integration we want to use dx or dy. If we want to use dx, we have to use the x as function, x equals to 2 minus y. If we want to use the inner integration as dy, we have to use the function of y. So as me, I use the function of x, so I use dx and I got this. For your information, this thing just for the inner side. For the outer side, just write back 2 until 0 because the limit is less than 2, so 2 until 0. So for the graph, as the question say x plus y less than or equal to 2, so we can determine that when x equals to 0, y is equal to 2. Is to 0 and x is equal to 2. So we can determine in the graph when y to 0, x to 0. When x is less than y, so the x will be at the left. When y is less than x, the y will be at the bottom. So that's why the graph is sketched at the left and the bottom side of the line. For the last question, so how to find the mean of x? There are two ways to find mean of x and mean of y. My way, I use this kind of way. I find the gx first. So gx with the limit of y. So the limit of y is this. Limit of y 0 until x, 0 until x. So I integrate, I get 8x cubed over 2. And the important thing is this 0 less than x and less than 1. Mean of x, take the limit 0 until 1 because this is 0 until 1. 0 until 1, x multiplied with gx dx, and I get 4 over 5. So for mean of y, I find the marginal density of y, that is hy. So I use the limit of x, y less than x and less than 1, and then I integrate it, and I got 4y minus 4y cubed. So and the important thing is the limit of y, 0 0 less than y less than 1. The mean of y is multiply y with marginal density of y and using the limit of 0 until 1. 0 until 1, and I will get 8 over 15. Okay, for the mean for x, xy, the formula is the limit using this 0 y x 1. Like I said for the question just now, use either one, the inner integration. Either you want to use the limit of x or the limit of y. Inner integration, I use the limit of x, so I use dx. So and I got 4 over 9. Equation for covariant x and y is mean of xy minus mean of x multiplied by mean of y. So we get the mean of xy, the mean of x, and the mean of y just now. So we just put in the data 4 over 9 minus 4 over 5 multiplied by 8 over 15. So it equals to 4 over 225. When the covariance of x and y is not equal to 0, so the x and y are not independent.